In this video, we'll be looking at the law of sines. Remember from geometry that a triangle has 6 parts. We've got 3 sides and 3 angles. So we're going to label the sides with our small a, b, and c, and our angles with a capital A, B, and C. A triangle can have its size and shape determined by 3 parts, providing they're the right 3 parts. We can prove a triangle by angle, angle, side. We can use angle, side, angle. We can use side, 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 and we can use side, angle, side. The other two are angle, 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 and side, side, angle. And we cannot use those to determine the size and shape of a triangle. Once we know 3 different parts, we can use trigonometry to determine the other 3 parts of the triangle. The law of sines says that the ratio of the sine of an angle to the length of the opposite side is the same for all 3 angles of any triangle. So the ratio of the sine of A over A is the same as the sine of C over C and the sine of B over B. It's a ratio, so it doesn't matter if it's written in this format or in this format with the sines on the top and the sides on the bottom. So let's use this information to solve a triangle. If we're given 2 angles and a side, first thing we want to do is draw a triangle ABC, and it doesn't matter. We're not going to try and draw it to scale. We're just going to draw a triangle and we're going to label it ABC. Angle A is 38 degrees. Angle B is 46 degrees. And the side A, which is the side opposite angle A, is 9. So we want to solve for the remaining 3 parts of the triangle. First thing we want to do is to determine the angle of C, which would be 180 minus 38 minus 46, which tells us that angle C is 96 degrees. Now we can solve using the law of sines. We can solve for the remaining 2 sides. We'll take the sine of 38 degrees and we'll divide by 9, and that will equal the sine of 46 divided by B, side B. With any ratio, multiply on the diagonal and divide by what's left over. When you're doing these, we want to leave the numbers in your calculator as much as possible instead of rounding, because as soon as you round, we'll start getting rounding errors. So multiplying here, we'll have 9 times sine of 46 is equal to sine of 38 times B, running out of room there. So we divide 9 times sine of 46 divided by sine of 38 will tell us that B is approximately 10.52. That's the side B. I need to clear this off to give us more room to find the side C. Now we'll set up our ratio for side C. We can do it with the sine of A and A or the sine of B and B, but because A was the one that was given, it's always a good idea to go with this just in case we made an error in our calculations here. We don't want to compound that in figuring out C. So we'll take the original sine of 38 over 9 equal to sine of 96 over C. So we'll get C times sine of 38 is equal to 9 times sine of 96. And so C is equal to 9 times sine of 96 divided by sine of 38. So when you put that into your calculator, you should get C is approximately 14.54. And now we have solved that triangle. And here are the 6 parts of the triangle that we just solved. Try this one. Solve the triangle if A is 49 degrees, angle A is 49 degrees, side A is 32, side B is 28. You want to round your angles to the nearest degree, and you will be using arc sine to find this. So step 1 would be to draw your triangle and then solve for the parts. Pause the video, work it out, and then I'll give you the answer. Let's work out another one together. We're going to find the height of a pole. If we have a rope sloping 15 degrees above the horizontal, so here's our road at 15 degrees above the horizontal, and a vertical telephone pole stands beside the road, and here's our pole. The angle of elevation of the sun is 65 degrees. So here's our sun over here, and it's at 65 degrees. The pole casts a 15-foot shadow. There's our shadow. Downhill along the road. Find the height of the pole, which would be x. So solving this, if we have our telephone pole, we're going to assume that it's a straight telephone pole. That means that this is 90 degrees. So angle of BAC will be 180 degrees minus the 90 minus 65, which gives this an angle of 25 degrees. This ACB would be the 65-degree angle of the sun minus the 15-degree angle of the road. So 65 minus 15, oops, that's a 5, is 50 degrees. So this here is 50 degrees. Now we have 2 angles and 1 side, and we can solve using the law of sines. We can solve for x, which is the height of our pole. We'll get the sine of 25 over 15 is equal to the sine of 50 over our x. Multiplying on the diagonal, 15 times the sine of 50, and then dividing by the sine of 25 tells us that x is approximately 27.2 feet high. One more for you to try. I'll give you several of the steps, and I'd like you to pause the video and work it out. We've got 2 people walking toward each other on a path through the park. The path runs east and west, and a hot air balloon is directly above the path between them. One of the walkers, a female, so this is the female here, sees the balloon when looking east at an angle of elevation of 46 degrees. The other walker, a male, sees the balloon looking west at an angle of 72 degrees. The walkers are 55 yards apart. How far is the balloon from the male observer? Step 1 in any problem is always going to be to draw a picture. Well, the picture has been given to you. Step 2 would be to determine what you're looking for. We're looking for how far the balloon is from the male observer. So that would be this distance there. Step 3, we need to find angle B. Since we already have this angle and this angle, that's pretty easy to find. Step 4, use the law of sines to find x. Pause the video and work it out. And now, just for fun, here's an equation for you. See you in class.